Lots of improvements and patches made to Linux and open source this week. We're going to be checking it out in this week's news. Let's get right into it. Nvidia just dropped the new 580.94.11 Vulkan beta driver for Linux, which finally adds support for the VK-EXT HDR metadata, which is the HDR metadata extension that's been available on Windows for many years. This new patch will enable proper HDR metadata handling under Wayland for Vulkan apps, which is exciting news as we finally get proper HDR handling, which has been a long-running problem, especially on Nvidia GPUs. Under Linux, this extension will help generate accurate HDR colors and brightness. Now, Wine and Proton apps already use this, so this helps Windows HDR games run correctly on Linux. And is a big win as Nvidia has supported this on Windows since around 2018. And of course, Linux lags behind. And it signals that Nvidia is continually trying to support gaming emulation and media playback on par with what we would see on Windows. It's nice to see this small win for Linux. I'll be following this as it gets released out of beta, as we have received a massive announcement from Valve last week with the announcement of 3 new products, including the Steam Controller 2, Steam Machine, and Steam Frame, a new VR headset. And it's really cool to see a breakdown of what the Steam Frame is using on its headset, as it's using Mesa's open source Turnip Vulkan driver for its Qualcomm Adreno GPU and not Qualcomm's proprietary driver. What we see here is in this post called Helping Valve to Power Up the Steam Devices from Igalia. Igalia has confirmed that they've been improving Turnip and helping Valve integrate it alongside FEX, which is the x86 emulation layer needed for running PC games on ARM-based Snapdragon architectures, which the new VR headset is based around. So last week, Valve stunned the computer gaming world by unveiling 3 new gaming devices at once: the Frame, the wireless VR headset, the Steam Machine, a gaming console in the vein of PlayStation or Xbox, and the Steam Controller, a handheld game controller, successors to highly successful Valve Index and Steam Deck. These devices are set to be released in the coming year. Igalia has long worked with Valve and SteamOS, which will power the machine and the Frame, and is excited to be contributing to devices, particularly the Frame. The Frame, unlike the machine or Deck, which has x86 GPUs, runs on an ARM-based CPU. Quote from Paulo here: "If you love video games like I do, working on FEX with Valve is a dream come true," said the engineer of Igalia's compiler team, as this is another big step for ARM gaming on Linux. Valve clearly is showing its continued push for open Linux gaming hardware, and I love to see a continued focus on the Linux gaming ecosystem, with Valve continually investing in open source drivers and using teams like Igalia to also invest even further in other architectures and drivers, specifically on Linux, as we gain more control and less dependency on vendor blobs, moving away from vendors like Qualcomm's proprietary Vulkan driver, which is closed source and very slow to improve. Turnip here lets Valve and the community fix issues, optimize performance, and support new features on their own schedule and on a Linux first system. Super fun. Now, of course, Steam's new hardware isn't without controversy, as Valve has not officially announced the cost of any of these systems, with a lot of speculation. People are claiming all over the board here from anywhere from $500 to $1,000 for the new PC that Valve is releasing, the Steam Machine, and whether or not they're going to try and subsidize it with Steam. But we have seen some confirmation from Valve that it was going to be more like PC pricing instead of console pricing. So it'll be interesting to really see what this means. I just can't imagine, at least with the specs that we're seeing, that it could really pull in PC-based prices, just because you could get your own PC and run a better system if it gets much over the $750 mark. That's just my opinion, but I want to hear yours in the comment section below. Let's move on to something else, as there's more news to cover. Here's a goofy one. After 21 years of being open, Firefox has finally added proper support for the XDG base directory specification in Firefox 127. So instead of dumping everything into a location of the home users directory hidden Mozilla folder, Firefox will now place config, cache, and data files into the correct XDG paths like home config and home local share. The long-standing 2004 bug request has finally finally been merged and closed. Wild to see this, as we now see cleaner and standards compliant home directories that actually follow the XDG rules. Can't believe this bug has been hanging around for decades now, and surprising that Firefox even bothered at this point. For those of you unaware, XDG is a set of standards created by the Free Desktop organization to make Linux desktops behave more consistently. It defines where files should go, how applications should integrate, and how desktop environments should communicate. So things like storing configuration files, user data cache files, how to find icons and menus on desktops. That's what XDG is. And originally it stood for X desktop group, even though it's widely just used as a prefix now and doesn't actually pertain to the X windowing system anymore. Anyways, interesting news from Firefox. As they keep taking away, they've finally given us better support for XDG-based directory specifications. Speaking about desktop environments, let's talk about this week in KDE Plasma as we gain UI and performance improvements. And the big one here to note is that KDE Plasma 6.6 is getting a major fix that finally lets desktop animations and effects run smoothly on high refresh rate screens. Think anything with a higher refresh rate than 60 Hz. This has been an issue for a while now, as it was a long-standing queue timing limitation. Plasma 6.6 also brings other performance improvements with KWin and better XWayland text input for games, memory leak fixes, and a more reliable systemd startup. But it's really cool to finally see high refresh users. Well, they call this high refresh. We're in the hundreds and hundreds of hertz at this point. But Plasma 6.6 will finally sync animations with the actual render loop, making the desktop feel dramatically smoother on fast monitors. You'll definitely want to upgrade to Plasma 6.6 if you have a high refresh monitor and you're using KDE Plasma. Might as well gain this capability by just updating. This brings Plasma closer to parity with GNOME and others which already have high hertz utilization on their desktops. It's cool to see as the team over there at KDE Plasma is constantly updating their desktop for the better. Love following around with KDE Plasma and their improvements. Happy to see them finally break that 60 Hz refresh rate limitation. Now here's another interesting one. FreeBSD 15 is out, and likely the final release candidate before the official 15 release in early December has some bad news for KDE. KDE was officially removed. Why is that the case? Well, they have a strict size for their DVD ISO image, which is 4.7 gigabytes. And FreeBSD chose to remove KDE from the main DVD ISO because the image exceeded this limit of 4.7 gigabytes, which kind of sucks for KDE, as it highlights the growing size of full desktop environment. KDE being removed due to ISO space limits shows just how large modern desktops have become and the dependencies behind them have come. For Linux distributions still shipping DVD size ISOs, this can foreshadow similar issues. It underscores the ongoing shift towards net install, minimal ISOs, and online package retrieval, as our modern software is just becoming too dense to package on DVDs anymore. But I thought this was an interesting one, as just recently FreeBSD was aiming to have a KDE desktop installation option by default whenever you wanted to choose a graphical desktop environment, but clearly we're running into issues. This was a recent announcement, and now it seems like we're going back, at least being able to put it on the DVD. Looks like you'll just have to get it from online if you still want to use KDE Plasma on FreeBSD. More desktop news as this week in GNOME, as GNOME 50 is getting released, the Nautilus file manager, the default file manager for GNOME, is getting a major speed boost for thumbnail loading thanks to new GTK4 features and fully asynchronous thumbnail loading. So here's what they mean by thumbnail loading. It's really when you have a gallery preview of things, and this is going to update much faster. Files landed 2 big changes by Khaled Abu Sharib this week. The first change adds a bunch of tests, bringing the total coverage of huge code base close to 30%. This will prevent regressions in previously uncovered areas such as bookmarking and creating files. The second change is more noticeable, as the way thumbnails are loaded was largely rewritten to finally make full sense of GTK4's recycling views. It took a lot of code detangling to get thumbnails to load asynchronously, but the result is a great speed up, making thumbnails show as fast as never before. Attached is a comparison reloading before and after the change. So this is a video I'm going to play real quick. Here's before, they hit reload and boom, that's the reload. And then the second one is the new reload, and you can just see how much faster it is. It's almost like it cached the first time. I would say after it was cached, it was just as fast, but definitely fairly decent desktop performance improvement. It can be annoying whenever it takes a ton of thumbnails to load in, especially if you're looking through many pictures. I do like the fact that GNOME is focused on a better responsiveness, less blocking, and better rendering profiles. Definitely cool to see this update. Now, of course, that's not all. We're seeing improvements to GNOME Calendar, which is exporting calendars as .icss. Finally, libadwaita has added prefers reduced motion support for users who want fewer animations, and officially a new user help website has now been launched, which helps you learn about GNOME if you're unfamiliar with tips and tricks, networking advice, and user and system settings. All great stuff. And if you also think this is great stuff, make sure to subscribe below and smash that like button on the way back up. You wouldn't want to miss another news segment, as this is an interesting one in CPython. 2 CPython core developers have proposed adding Rust to the CPython codebase. It would start with optional extension modules, but eventually make Rust a required dependency and allow Rust through CPython itself. The goal here is to improve memory safety, reduce bugs caused by unsafe seek, and modernize Python's development strategy. What we see here is a proposal introducing the Rust programming language to CPython. Rust will initially be allowed for writing optional extensions, but eventually will become a required dependency. So we get an update on this one. The motivation was as Rust has established itself as a popular memory-safe systems programming language and used by large numbers of projects. Memory safety is a property of programming language which disallows out-of-bounds reads and writes to memory as well as user after free errors. Rust safety properties are enforced by ownership mode for code, which ensures the memory accesses are valid. And with this proposal here, the community response was mixed but very serious, with a strong enthusiasm for Rust safety and modern tooling, but had a deep concern over the complexity and long-term maintainability, especially with Rust potentially becoming a hard dependency for CPython. Many did not like that. And that's why we saw this update of crossing out the hard dependency, and we get an update here by the original proposer. I wanted to start by thanking everyone for their feedback on the proposal so far and say that we look forward to continued discussion. After reviewing the discussion so far, we've decided to refocus the pre-PEP to only propose the introduction of optional Rust extension modules to CPython. We hope that with experiences gained from introducing Rust for extension modules, Rust can eventually be used for working on the required modules and interpreter code itself in the future. However, we will leave that to a future PEP when we know more, and I will not be proposing that as a part of our current discussion in the PEP, as there were some cautious reactions and concerns raised. One being, if they did include Rust as a required dependency, it is very heavy. People worry about small distributions, embedded systems, and minimal CPython builds when using Rust as a dependency. The toolchain can become complex. These concerns include increased toolchain burden, forcing contributors to learn a second systems language, and adding unsafe extra layers that still can carry risks, all while creating governance challenges around who actually maintains Rust code and how it would fit into CPython's long-term roadmap. So there's still clearly debate on how to get Rust into CPython. We'll be following this, as it's very interesting how more and more projects are introducing Rust, and how Rust is becoming more and more apparent in Linux and open source. In another project from Collabora, Daniel here posts about a new Rust-based ARM GPU kernel driver called Tyre. This is an alternative to the traditional C-based Panther driver for newer Mali GPUs, which has progressed to a point where it can now run GNOME, Weston, and even 3D games like Super Tux Kart. The claim here is that it's already matching C driver's performance in full screen mode and makes for a major milestone for Rust in the Linux kernel. Tyre here is real-world proof that Rust kernel drivers can match C driver performance, not just in theory, but actually running a desktop environment and games, and is a big win for ARM graphics. Mali GPUs are used in phones, tablets, single board computers, and other consumer electronics. A few months ago, we introduced Tyre, a Rust driver for ARM Mali GPUs that continues to see active development upstream and downstream. As the upstream code awaits broader ecosystem readiness, we have focused on a downstream prototype that will serve as a baseline for community benchmarking and help guide our upstream efforts. Today, we are excited to share that Tyre prototype has progressed from a basic GPU job execution to running GNOME, Weston, and full screen 3D games like Super Tux Kart, demonstrating a functional, high-performance Rust driver that matches C driver performance and paves the way for eventual upstream integration. And here's a video showcasing of how Tyre is actually running the GNOME desktop as well as Super Tux Kart. But that's not the only language that is rewriting programs. There's been an announcement from an OpenSUSE developer to implement SSH in Zig. A developer is currently working on a fully native SSH implementation written in Zig called zssh, and the project already supports keys, certificates, primitives, and parts of the SSH agent protocol. The current goal here is to finish the full SSH protocol with an emphasis on flexibility, especially for experimenting with new cryptography and post-quantum algorithms. And this was announced in SUSE's Hack Week 25 and is very interesting. Following Zig's philosophy of reinventing the wheel for the better, a while ago I started implementing SSH protocol in it, and now the aim is to finish the implementation. It's just interesting to see a rewriting of major open source code bases, just like we're seeing with Linux drivers, now SSH libraries, and maybe in the future CPython. As it's happening more and more every day, especially with languages like Rust, well, here's Zig. Go is another example. And the main reason most people seem to be rewriting things is what they claim memory safety issues in old C and C++ code. As C and C++ code make it very easy to introduce use after free bugs, buffer overflows, double freeze, data races, erase conditions, and undefined behavior if you're not careful. The claim is that languages like Rust can help with better testing, reproducible builds, safer concurrency, strict checking, and of course, probably the number one thing, adding a package manager. Well, this is all great, but there are issues with rewriting code bases, as it seems like everyone's trying to rewrite a code base. Not saying that this is a bad implementation, just saying it is a common trend right now. As even using Rust, Zig, and Go, the rewrite will inevitably miss edge cases, break compatibility, fragment code, and the hardest part is replacing stable code with untested new logic. Often, these rewrites end up abandoned as well, which we've already seen issues with. So I'm interested in what you think about the trend of rewriting everything in a different language. Why don't you take a second and post it in the comments section below. And also, while you're down there, if you're ready to level up your Linux experience, check out my checklist, cheat sheet, and mind map, all available at SavvyNik.com. Download them today. Here's another interesting one. Canonical, the company behind Ubuntu, has submitted patches for RISC-V support to Flutter, which Flutter is a cross-platform UI framework created by Google. It lets developers natively compile apps for Android, iOS, Linux, Windows, macOS, really everything. But now we're starting to see RISC-V support being added in. Ubuntu's own Flutter-based tools like the installer, App Center, and Security Center will now be allowed to run on RISC-V hardware. Until now, Flutter had no official RISC-V support, and with Canonical's work here, Flutter can now be built and cross-compiled for RISC-V 64-bit on Linux. It's another architecture support here, which is very interesting that Canonical's Flutter team is focused on this. And of course, this is a big win for RISC-V desktop ecosystems. RISC-V is the only major fully open CPU architecture, and this strengthens Canonical's and Ubuntu's push into open hardware, as clearly they're trying to become the default operating system for many RISC-V boards. And they got a clear focus here. We'll see how Canonical keeps focus on RISC-V, as this is an interesting step forward. Now, what's Linux without some major performance improvements? As AWS engineers submitted Linux kernel patches that massively speed up nested virtualization on Intel hardware. How is this done? Well, it was done by replacing slow map and unmapped memory operations with a smarter caching system. And by fixing these issues, they achieved up to 2,300 times faster memory unmapping in synthetic benchmarks on AWS's EC2 Nitro instances. The improvement also fixes stale mappings, invalidation bugs, and performance bottlenecks in nested virtual machines, and is a big win for cloud platforms and sandbox systems, aka using virtual machines. So this really just optimizes Linux for cloud providers. Clearly, AWS has a big reason to do this, as it creates better performance for their EC2 clusters and faster nested virtual machine workloads for cloud native development. And here's the micro benchmark using memory slot performance tests with 8,192 memory slots, and demonstrates how nested VMX operations with unmanaged guest memory behaves. So before with mapping, 26.12 seconds, after 1.54 seconds, a 17 times improvement. Unmapped 40 seconds, and now that's 0.07 seconds. That's 17 milliseconds, 2,353 times faster. And unmapped chunks 10.07 seconds down to 5 milliseconds, 2,014 times faster. Now this isn't going to help everyone, but hopefully patches like this can make cloud services faster, cheaper, and more reliable as they focus on real optimizations for nested virtualization. So every everyday users will really see this on things like Netflix, Spotify, Discord, anything really that runs in the cloud, not necessarily for their own local virtual machines, as the operations done at scale don't really add up. But your applications, cloud services, update tools hopefully become faster, cheaper, and more reliable because Linux is the foundational technology that runs the internet, and improvements like this end up helping us long term. It's always great to see these types of patches. So let's see another patch that brings a bit of an improvement, as Glibc just removed an old 96-bit long double FMA fuse multiple add implementation and switched to a faster 64-bit double precision FMA implementation. So now on modern CPUs, especially on AMD Zen 3, this new implementation gives 4 times faster math throughput and latency with a 2 to 2.3 times gain over older 32-bit i686 mode. This will officially ship with Glibc 2.43 in February. Of course, this introduces faster performance on every single Linux system using Glibc, and currently Glibc is pretty much the default C library for almost every mainstream Linux distribution. As the code's been optimized for modern CPUs, such as AMD Zen 3 and above, this will also work in other modern CPUs. It also removes some legacy complexity and simplifies Glibc just a little bit. It's always exciting to see updates like this, as a 4 times improvement on x86 64-bit with this specific instruction is very cool to see. And finally, I don't know what's going on at Google over there. As Google removed JPEG-XL support in 2022, and I covered this back then, claiming there was an insufficient interest and that other codecs like WebP and AVIF already covered most use cases, as this angered developers because JPEG-XL offered better quality, lossless transcoding, and lower bandwidth, and with a modern feature set. Now with other browsers having official support, including Safari and Firefox updating its stance, developer demand has increased, and Google is now looking at bringing JPEG-XL back. So anyways, this is the original JPEG-XL decoding support back in February 12th, 2021. The description rationale was that JPEG-XL is a new royalty-free image codec targeting image quality as found on the web, providing around 60% size savings when compared to the original JPEG at the same perceptual quality. JPEG-XL is based on Google's PIC and Cloudinary's FUIF formats. The format is frozen and the spec is in its final steps of standardization with ISO. It includes features that we've already mentioned, and now pushing forwards into 2025. The back and forth is here. Since JPEG-XL was last evaluated, Safari has shipped support and Firefox has updated their position. We also continue to see developer signals from bug upvotes, Introp proposals, and survey data. There was also a recent announcement that JPEG-XL will be added PDF. Given these positive signals, we would welcome contributions to integrate a performant and memory-safe JPEG-XL decoder in Chromium. In order to enable it by default in Chromium, we would need a commitment to a long-term maintenance with those of our usual launch criteria met. We would ship it in Chrome. That's right. As of November 21st, 2025, Chromium's back to looking for someone who could write out the JPEG-XL decoder for Chromium. And while originally Google removed JPEG-XL saying nobody wants it, now only later to admit that others are shipping with and people clearly want it, including developers. While Google has already pushed WebP and AVIF, JPEG-XL clearly competes with them, and now Google wants someone to write it out for Chromium. Whatever, I just think it's kind of annoying. As I followed this through back in the day, we'll see how things pan out for Google and Chromium. Either way, it would be nice to see the JPEG-XL decoder in Chromium, since so many browsers are based around Chromium. And that was a lot covered in this week's Linux and open source news. If you enjoyed this, don't forget to subscribe below and smash that like button for more. Catch me in a great community on Discord, and I'll catch you in another video. Thanks for watching.